Welcome. In this video I'm going to show you how you can obtain the effect size measure V using Microsoft Excel. This is an effect size measure that could be used after a goodness of fit test. It actually takes the observed chi-square test value and divides it over the maximum possible one, and then takes the square root out of that. I have a separate video where I simply show you how this can be done with my stikpet E add-in, but in this video I won't be using that. To show you how to obtain this, I have some example data in column A, and the first thing I do is I create a frequency table out of it. So I take the different categories, use a simple count if function. Notice that I'm using a semicolon to separate parameters. That could be different in your version of Excel, where you might be using a comma. So apparently there were 79 people separated. As expected count, I'm simply going to actually assume that each category was equally likely. So I take the total, which is the sum of all the frequencies, and divide it by 5 in this case, because I have 5 different categories. My expected proportion is then simply this expected count divided by that total. The reason why I'm doing all of this is because I need a chi-square value as well. So the chi-square value can depend on which test you're using. So for a Pearson chi-square test, what I could do is I take the frequencies minus the expected, square the result, and divide by the expected count. I do that for each category, and eventually I can then sum these up to get a chi-square value. I have a separate video on how to actually perform a chi-square test of goodness of fit and also different variations on those. I need a minimum expected count. In this case they're all equal, but you can simply use Excel's min function. And that should be all that we need to complete this formula for phi, which is actually the square root. So we're taking the square root out of something. Then the chi-square value, that's the one we calculated over there. We divide that by, and then we take the sample size n, so that's the total, times 1 over, and then the minimum expected count, which we had over here, minus 1, so that's the minus 1. Close all the parentheses, or brackets if you will, and apparently our phi is about 0.40. It's possible to actually convert this to a Cohen W. And the reason I'm mentioning that is because you can then actually use the rules of thumb for Cohen W if you're interested in that. Alright, I hope this video was helpful, and thank you for watching.